Hello students, and this video I will be solving some of the questions from the test of mathematics at the 10+2 level book for the ISI entrance examination for 2018 session. Okay, so some of the students have requested me all over India for solving the 117th question from the book called Test of Mathematics at the 10+2 level. So I'm going to solve it. The question is the coefficient of x square, in the expansion of 1 plus x square whole to the power 10. So what is the coefficient of x square in the expansion of this? So now you can see that this can be expanded very easily like this, that 1 plus x square whole to the power 10 can be rewritten in the format as 10c0 1 plus x whole to the power 10 plus 10c1 1 plus x whole to the power 10 into x square, and in this pattern it goes on and on. So obviously we can write 10c0 is 1, so 10c1 into x, 10c2 x square dot. So these two plus, here we can write 10c1 along with that 1 plus x dot whole into x square, and this way it goes on. So obviously we get two terms here. So one is this term, that is the coefficient 10c2, and the next term is 10c1, and this is x square. So ultimately we can write that 10c1 plus 10c2 is the coefficient, so the option A is correct. The next is 118 number question, and this is also similar to the above one. Now here log of 1 plus x square, and they asked me to find the coefficient of x to the power 17. So see, if there's a log, you have to introduce a term in the denominator also. So what I'm doing is I have to get a formula of two terms, so I have to make it a cube. And the easiest way is this: just divide by 1 minus x and multiply by 1 minus x. So simply the numerator has become log of 1 minus x cube divided by 1 minus x. So this can be rewritten as log of 1 minus x cube minus log of 1 minus x. This is very much important. So we can write it like this: log of 1 minus x cube minus log of 1 minus x, and you can just simply expand it. Log of series, I have already done it in my previous video. Okay, so let's expand it: minus x cube minus x6 by 2, and we can write it in this format. And in the right-hand portion also we can write it like minus x square by 2 dot, and there will be at minus x to the power 17 by 17, as the power of 17 is being asked. So it's like this. So every time we will multiply, things will be cancelled, and we will left out with the term 1 by 17. These two minus will ultimately make it positive. So 1 by 17 x to the power 17 and plus. So obviously if we go through the options again, so we can see the possible option is only A. So this is the way to solve the problem. Now there is another question I would like to solve, that is question number 120. Let me just give you the brief idea of the question, that there are 3 boys in a class. So 3 boys. Okay, I know it's not a good painting unless these boys are the representatives of the 3 boys, which is this said about the question. So there are 3 boys in a class 1, 4 boys in class 2. This is class 1, 4 boys in class 2. So we are drawing a relatively bigger size of boys, and 5 students in class 3. Okay, so not only their heights but also their total numbers are increasing according to the higher classes. they sit in a row, the number of ways they can sit so that boys of the same class sit together. Boys of the same class sit together. So it's a very easy structure. So here let the boys of each class as a unit. Okay, so this is unit 1, this is unit 2, and this one is unit 3. Okay, and therefore there are 3 units which can be obviously 3 different units that can be done it in factorial 3, that is 6 ways. Now class 1 boys can permutate among themselves in factorial 3 ways again. Class 2 boys can do it in factorial 4 ways, and class 5 boys in factorial 5 ways. So ultimately total ways in factorial 3 into factorial 3 into factorial 4 into factorial 5. So this is factorial 3 square into factorial 4 into factorial 5. So option C is the correct answer over here. Next is a question being asked, and I'm going to solve the question. This question is question number 126. So they said the number of odd positive integers smaller than or equal to 10,000. Smaller than or equal to 10,000, which is divisible by neither 3 nor 5. Not divisible by 3, not divisible by 5. Okay, let's proceed. So let n be the number of odd numbers divisible by 3. Okay. So then we can say it like 3 plus n minus 1 into 6, utilizing a formula 9999, and here n will be 1667. Let another one as, let it be n1, okay, and n2 be the number of odd pairs divisible by 5. So in case of that, it will be 5 into n2 minus 1 into 10 equal to 9995. Remember that I am taking the closest possible multiple of 5 in this case. Okay, so I'm going to solve it again, and n2 will be here as 1000. So we're getting a whole number, that's cool. And let n3 be the number of pairs divisible by the product of 3 and 5, that is for 15. So in that case it is 15 and n3 minus 1, and that will be 30, the double, equal to 9975. Okay, and here if we just divide, so n3 will be here 333. So this we just solve it. So the number of odd numbers divisible by 3 or 5, 3 or 5, we just have to add their numbers like 1667 plus 1000, but we need to subtract this portion. It is like this. If you just find this area, so this area full and this area full, and the innermost area is calculated twice, so that needs to be subtracted. So answer is 2334 different possible combinations. So the number of odd numbers which are neither divisible by 3 nor by 5 is, so how many numbers are there? 5000, and these are divisible ones. So 5000 minus 2334 equal to 2666. Hence the correct option is B. Okay, now I will proceed to some more questions in my next video. Okay, don't forget to subscribe my channel, and this subscription will lead you to my next videos as well.